Returning to the noisy channel theory of language processing, recall that this theory is an adaptation of Shannon's abstract model of a communication system from the dawn of information theory in 1948 with his seminal paper. In this abstract model, there's an information source that has a message to be encoded. It's encoded, and a transmitter emits a signal. That signal is potentially distorted through noise. The receiver receives that potentially distorted signal, and then at the destination, the distorted signal is interpreted, and the goal is to recover the original intended message from the information source. In the adaptation for studying human language production and comprehension, we'll call the intended message M, and M is encoded in the language production process into an utterance U. U is then the signal that is potentially distorted through noise. Those noise sources include the noise in the environment, the imperfection of the perceptual systems of human language comprehenders, the fact that our memory is not perfect and language comprehension requires integrating present input with past memories because language comprehension happens over time. And depending on the scope of what we are interested in studying, we may also make a distinction between the intended utterance and the actually produced utterance. The intended utterance is sort of in the abstract what the speaker would have said if they had not been subject to real-time performance constraints, and the actual utterance is the thing that the speaker really said. And there is a potential discrepancy between the two, and we can also think of the discrepancy between the intended and the actual utterance as also a source of noise. That potentially distorted noised signal that is the beginning of the comprehension process then is decoded through a process of inference to recover the message that is inferred as the most likely intended message by the speaker. So the process of comprehension is reverse engineering what the likely message M is that was probably intended by the speaker. So, for example, we can model inferences over the intended message M. Bayesian inference says that the input I guides that inference through joint reconciliation of the prior, P over M, what message was a priori was the speaker likely to intend to mean, and the likelihood, P of I given M. That is, how likely would each possible message M render the actual input to comprehension. We can also, of course, model with things like what was the intended utterance, U. Likewise, this would be P of U given I, once again reconciled by likelihood and prior. One way that we might want to study this, so in previous lectures, we looked at the incremental real-time comprehension process, but a very simple question is, well, given the setup that we just looked at, it would be very natural to study simple question answering. And in what cases is there an interesting sort of discrepancy between the surface form of the utterance that is offered to the comprehender and what the comprehender infers the sentence to be likely to mean. So let's look at some simple examples. This is using a very simple question answering utterance interpretation paradigm. It's been used in many, many contexts. One example is the work of Ferreira 2003, which was further developed by Gibson et al. 2013, which we're going to spend a fair amount of time on today. I'll just give you some examples of this, and you can just follow along and listen to your intuitions on this. So, for example, if the sentence is the woman lost the diamond, and I ask you, did the woman lose something? Then it's probably very obvious to you that the answer is yes. The woman lost the diamond. What about this? The ball kicked the girl. Did the girl kick something? Now, this is probably also quite clear. This is a very weird sentence in terms of the plausibility relations. Balls can't kick things. Nevertheless, despite the implausibility, you probably had no trouble successfully answering, no, of course the answer is no. The ball is doing the kicking, the girl is getting kicked. In the sentence, so the girl didn't kick anything. What about this? The businessman benefited from the tax law. Did the tax law benefit from anything? The answer is once again no. It's the businessman who benefited from something, namely the tax law. And finally, the cook baked a cake, Lucy. Was something baked for Lucy? Now, the answer to this, according to the grammar of English and to the sequence of words, the order of the words in the sentence, is no. Something was baked for a cake, not for Lucy. But you may find yourself having a hard time successfully saying no, or it might have been a little bit more difficult to get an answer to this question than for the first 3 examples. And so you might have had an initial gut instinct reaction that the right answer is, or maybe the right answer could be yes. And in fact, actually, this is a pretty common tendency. So if we do experiments on this at scale and we ask people these questions, then it actually turns out for this kind of example on the bottom, over 2/3 of answers are actually yes answers. It's quite striking.